All right, good learners, lesson number 6. And lesson number 6 is dedicated to just trying to put everything that we learned together. And in getting to lesson number 6, which would last for about an hour and a half, I want us to quickly run through a few things. You see, we did a lot of work, so please, so much work has been done. Check. We've gone through how many slides? 43 slides. 43. So please do yourself a favor, get the lessons and catch up before you get to school. It's always nice to stay ahead. All right. Let's quickly look at something. Consolidation of content. Let's summarize quickly. What are the things that I need to know? First, let's make a list of definitions that we talked about. Number 1, we spoke about, let me go back. We must be able to define a vector quantity, a quantity that has both magnitude and direction. Number 2, we defined momentum. Momentum is the product of mass and velocity. All of this has been done. Number 3, we defined linear momentum. We said linear momentum is momentum in a straight line. Number 4, then we dealt with law of conservation. Before we do that, we defined isolated system. A system where there are no external forces. Then number 5, we defined the law of conservation of linear momentum. That in an isolated system, the total linear momentum is conserved. Then number 6, we spoke about elastic collision. A collision where both kinetic energy and momentum are conserved. Then we spoke about inelastic collision. Momentum is conserved, kinetic energy not conserved. Number 8, we then went to talk about impulse, which is the product of net force and time. Then number 9, we spoke about the law of conservation of mechanical energy. First, let's look at, we defined mechanical energy as the sum of kinetic and potential energy. And number 10, we spoke about the law of conservation of mechanical energy. So please, this is your checklist. Can I define all of these 10? You are now in grade 12. You know the implication of not knowing your definitions. You know it's -2. And it's not just that. The definition carries the entire topic with it. So definitions. Now, what concepts did we learn? Number 1, we learned about the concept of momentum itself, that P equals to what? mv. And then we said momentum can be represented by vector diagrams, where we use an arrow to represent that. Then we learned about the change in momentum. That delta P is equal to m delta V. We did all of that on that momentum. And then we did calculations of collisions. And we had 4. Case studies. Objects are together, before separated, after. Those of you that were part of that class, you would know. And if you were not part of that class, this is what thing you should put a note. Just put this note down to say, these are things I should go and learn. All right. Then we spoke about collisions, how to deal with elastic and inelastic. Oh, there's another definition I forgot. Let me just add it there. Newton's laws. Newton's second law in terms of momentum. Newton's second law in terms of momentum. We stated that law as well. Very, very important. And in terms of concept of physics, Carmo, you are watching a movie, you are eating, you are in class, all the three at the same time. You are a superhero. All right, if they are watching TV, they just move a bit. Okay, sometimes we understand. Okay, concept of collision. Then we did the concept of impulse. We looked at the impulse and change in momentum theorem, where we proved that impulse is the same as change in momentum. And number 4, we looked at graphs. So for today, let's see if we can get through 8 questions. I'm always very ambitious. If you have been following, I'm ambitious. I want to look at 100 questions. But we will try to see what we can do. I want to please make sure you try to follow. Some of you have forgotten, even those that were here have forgotten. Some of you were not here when we did those classes. Please maximize your weekend. The race has begun. Okay, somebody can just take a picture of this and we have it on the group as a guideline of what we need to know. It's always good to have a checklist. If someone can be kind enough, just get a picture of this, put it on the group as a guideline, a checklist. When you are working on your own, you are ticking off these things. Can I do this? Can I do that? And then we get into calculations. Somebody in? So even if you are not part of the lesson 1 to 5, don't log out, just hang in there. You will get certain things tonight. You will get certain things. Thank you for sending it through. You would get certain things. Okay. Kutrano, thank you very much. Now let's look at this question. So I'm going to try to bring you up to speed gradually. A bird of mass 800 grams. Please, there's a problem there. 800 grams already is a problem. Mass is calculated in kilograms. So the mass will be 800 divided by 1,000. Can you see I stopped immediately to correct that? Very, very important. You don't continue with errors. You stop, correct it, then we move. All right. A bird of mass 0.8 kilogram is flying horizontally and has a 40 joules of kinetic energy. Okay, so the bird is flying with a kinetic energy of 40 joules. The bird lands on a small stationary toy car. It lands on a small stationary. Stationary tells us that the velocity there is 0. So the velocity here is 0. Of mass 200 grams. Again, we change the mass. 200 over 1,000 Now you can, if you notice, I'm quite slow. Why? I want us to get into the story of the question before we start calculating, because we must know what we are doing. Now, the bird toy car combination, please check that. The bird toy car, that is the bird and the car combination, moves at a constant velocity until it collides with the wall, coming to rest in 0.05 seconds. With physics, you pause. Do I really understand what just happened? So, let's see. The bird is moving, right? Lands on a toy car, and the bird forces the toy car to then move. Number one, define the term linear momentum. Beautiful. Do you see that? And that's part of the definitions we spoke about. So, 4.1. What is linear? They didn't say momentum. Linear momentum. It is momentum in a straight line. If the examiner had said define momentum, then momentum would be a product of mass and velocity. All right, look at the next question, 4.2. Calculate the speed of the bird toy car combination immediately after the bird lands on it. Please, in case you missed it, this is what we do. Here, we are using the law of conservation. So, this is what happens. They were separate before, okay? Separate before, and now together after, because it says the bird car combination. So this is the bird, this is the car, this is the bird car. Each of them, let's call this 1, 2, 1, 2, will have its own momentum. So we would say sum of initial momentum. We did this in maths called sigma. But let's break it down further. M1 VI1, because momentum is a product of mass and velocity, plus M2 VI2. So this aspect is called initial. And when they now combine, it's called final. All right? So the sum of initial momentum is equal to the sum of the final. Anytime they move together, we can just add the masses, which is M, and they have the same. Please, I want you to notice that we have maintained something. We have maintained that momentum. We are maintaining this. Momentum P equals to mv. That's what I wanted to see. That m times v for the first, m times v for the second, m times v. I needed to see that. Let me know if you are able to see that we're using the momentum formula. Just give me thumbs up. Sum of momentum before is equal to sum of momentum after. Why am I adding the after? They move together, so we say m1 plus m2. Okay. Now, the bird has a mass of 0.8. Oh, wait, hold on. The examiner, all right, beautiful. The examiner did not give us the velocity. They gave us the kinetic energy. Okay, so the kinetic energy of the bird was given half mv squared, which is what? 40 joules. 1/2. What is my m? 0.8. Okay, please do the math for me and get me v. You are now in grade 12. No spoon feeding. Get me v. Everybody working now. Let's see your maths. So I couldn't work this out without first getting the initial velocity. So let's work it out. Once you have an answer, let me know. Lusanda has 16. Or it's a 4. Busi has 10. Okay, guys. We need to get the same answer. So let's look at it. Noku has 10. Lusanda, do you want to recheck? All right, everybody seems to be getting 10. So Lusanda, is there something that we did wrong? Hi, Rosemary.
Hi, sir.
Long time no see.
Yeah.
You were just enjoying your Christmas and New Year stuff, not remembering me. No problem. I will make you suffer. Just joking. All right, let's see. So what do we do? If we multiply, that would be 80. So 40, or so. I'm not sure what you did there, Lusanda. There are two ways of doing that. You can say half times 0.8, which will be 0.4. Then you say 40 divided by 0.4, that gives you 100. And then you find the square root of 100. So I believe the answer of 10. Are we on the same page? Okay, so 10. Now, we now have the initial velocity, which we can then take back into that formula. Okay, so I am going to recreate my page. So we said M1 VI1 plus M2 VI2 equals to M1 plus M2 final velocity. The mass 0.8, velocity is 10, plus the mass 0.2 of the car, but the car was stationary. Now, both of them added together. Now, please give me the final velocity. Do the math again. Let's see your maths. Final velocity. Oh, people are getting 8. Is that correct? Okay, let's see if it's 8. I think it is 8. So what do we do? 0.8 times 10 would give us 8. That would give us a 0. And that would give us 1 VF. All right, so VF, therefore, is 8 meters. Now, go back to the question. Let's check something. What are we looking for? Calculate the speed. So we are fine. Please look at 4.2.1. The examiner wants what? Speed. Now, I'm just going to put this in a block. If the examiner wanted velocity, then my answer would have been, just take note, 8 meters per second in the direction of motion or towards the wall. Okay. Please take note, I'm trying to teach you something, the difference between speed and velocity. The examiner wanted speed, so we're fine. But if they wanted velocity, you have to include direction. So that's it. That's done. Thank you for giving me that 8. Calculate the magnitude of the net force exerted on the bird and the toy car by the wall. Magnitude of the net force. Oh, good learners. Every time I see magnitude of net force, I know I am talking about something here. So, what is this? 4.2.3, I think? 4.2.2. Check. Net force equals to what? Delta P over delta. This is Newton's second law of momentum, second law of motion in terms of momentum. That the net force on an object is equal to the rate of change of its momentum. We did that as well. Now, so this is m delta v over delta t. So we can quickly then substitute. Now, remember it's the boat, the toy, and the car, so the mass is 1. Now, what is the final velocity? Okay, hold on, before I even start substituting. So we see m vf minus vi over delta t. Okay. Now, their combined mass is 1. Their final velocity is 0. And their initial velocity is 8. And the time, I think it's 0.05. Let me go back quickly. Yes. And I quickly want to ask, why am I saying the final velocity is 0? I'm not just assuming or making it 0. We're given. Look at the last line. Coming to rest. Coming to rest. You see that word? In 0.05 seconds. That's why my final velocity of both objects is 0, initial velocity 8, and that. Do you want to give me an answer to this? We should get a negative. $160 or something. Is there a question? Buitumelo, my screen appears. You need to choose the right crazy physics. You need to find it. There are about 3 crazy physics there. So just check. My screen is very clear. That's why people are giving me answers. Lusanda has given me an answer. Busi has given me an answer. Let me know if you're fine now.
I'm fine, sir.
All right, beautiful. You're welcome. Negative 160. But the examiner wanted what? Magnitude. So what do we say? Just 160 newtons. The negative is for direction, okay? Because the wall is acting in the opposite direction. Without any calculation, write down the magnitude of the force exerted by the bird toy car combination on the wall. Look at 4.2.2. Calculate the magnitude of the net force exerted by exerted on the bird toy by the wall. Please get it, by the wall. Look at 4.3. Without any calculation, write down the magnitude of the force exerted by the bird toy car on the wall. I hope you see the whole story there. One is on the wall, second one by the wall. And your answer would be the same. 160 newtons. Why? Because of Newton's what? Third law of motion. Did they ask us to state? Let's look at it very well. They said, name the law that you applied. Name the law. If they said name and state, then you state. This is naming the law. 1 mark, 1 mark. Newton's third law of motion. Are we okay with that? We're done with that question. Can you see? Easy peasy. You just understanding what you need to do makes it easy. All right, question dealt with. Let's look at this one. 10 marks. 10 marks. Please follow. You'll get it. In case you were a bit lost, you'll get it. And feel free to ask. Please, feel free to ask. 2 trolleys are placed on a frictionless track in a physics laboratory. A compressed spring is placed between the 2 stationary. Please, don't read blah, 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 blah. 2 stationary trolleys. And you will notice they said they are held together, so they are combined. Trolley 1 has a mass of 5. Let's call this trolley 1. 500 grams, which is a problem. 0.5. Don't make a mistake. Don't calculate in grams. And trolley 2, 300. Again, we change. 0.3 kg. The spring is released and trolley 1 moves away with a velocity of 2.4. So I'm just going to write this. So trolley 1, right? Okay, definitely it's going to move in that direction. All right. So we have all our information. Please work with me on this. State the law of conservation of momentum. Now, if you check, all the definitions are what I told you they will ask you. The total linear momentum in an isolated system is conserved. And first 2 marks in the bag. 2/10. That's where to start from. 2/10. Calculate the velocity of trolley 2 after the spring is released. Please observe what's going on. These things were together at first. All right? So we are doing, I think this is case study number 3. If you go back to your notes, they were together at first. Now they are separate. Please, I wanted to watch something very, very important. This was where some of us were making a mistake the last time. Okay. Object 1, object 2, object 1, object. Since direction is now opposite, you have to pick one direction. Okay. So let's say take left as positive. It doesn't matter where you take that, you take it as positive or negative. Doesn't really matter. Let's see something. Take left as positive. All right. Since they are together, we can add. Can I squeeze it here? M1 plus M2. Now, this becomes my initial. After is always the final. M1, VF1. We maintain momentum, mass, and velocity. All right, what we have? 0.5 plus 0.3. By the way, they were stationary. Velocity is 0. What is the mass of 1? 0.5. I said take left as positive. So, trolley 1 moves to the left. This one becomes 2.4. Plus M2. What is the mass? All right, do the honors for me. Please get me VF2. You need to state whether it's positive or negative. So quickly do the calculation for me. We are moving. We are moving. We are moving now. I'll be waiting for answers, please. Busi, before you give me the direction, did you get a positive or a negative answer? Because I want us to see something there quickly. All right, Busi gave me a negative. Guys, I want answers now. Buchmelo, I need the sign as well. Are you getting a positive or a negative? Jara Ahmad, you have a 0.8. Okay, guys, let the answers start coming in. I'm seeing different answers, so we need to find out which one is correct. All right, I have another answer. Lysandra is giving me 1.5. Okay, guys, that means there's something wrong with the maths. I already have 3 different answers. Ooh, something is wrong somewhere. Okay, answers are now coming in as 1.5. Buchmelo, you have a positive answer. Okay. Are you sure? Guys, are you also getting positive 1.5 or negative? Please put the sign. I need to see the maths. It means we're doing something wrong mathematically. Lysandra also gave me a positive, so positive. Rosemary, guys, how is this positive though? From where I'm sitting, I'm already seeing a negative answer. Okay, let's walk through. Guys, are you still on holiday or what? Brains are still fogging. 0.5 plus 0.3, 0.8 times 0. This would give us a 0. All right? 0.5 times 2.4. 0.5 is half. So half of 2.4 is 1.2. Guys, how are you getting 1.5? How is that possible? Are you adding these two together? Oh my Lord God of heaven. Mango plus oranges is called mango range. Is that what you guys are doing? Banana plus oranges, banana range. Hallelujah. What you are doing, guys? How can you add 1.2 plus 0.3 VF2? You guys need to be shamboked. Real shamboked. Can we move that 0.3 over? Negative 0.3 VF2. Then we divide by what? Negative. Answer is negative 4. What you are doing? Matrix. Now, do you notice the examiner wants us to find the what? Please, always come back to the question. Velocity. Oh, which means we must have both magnitude and direction. You guys, you really need extra class. Now, do you remember we said take left as positive? It means our negative then becomes right, which makes a lot of sense, even from the diagram. Guys, I don't know your 1,5. You guys are smoking something. Whatever you smoke during the festive, please drop it. Start drinking water. Yeah. You always smoking something. You are high. Honestly, you guys are high. High. Please, water. Water it's very hot, so stop smoking things. Water is key. But are we okay with what I did so far now? Are we okay? Very, very important, people. Please, very, very important that we do the maths right. Okay. Now, can I move on? Somebody can take a picture of this quickly. Send it on the group for reference purposes. If the release of the springs takes 0.12 seconds, calculate the force which the spring exerts on each of the tray. Okay, let's see something here. The spring release takes 0.12 seconds. We're looking for the force. Guys, once I have time, I'm going to come to this formula. F net equals to delta P over delta T. All right, what is this? M delta V, which is MVF. Okay, I want us to see something here. Let's work with the 500. Let's work with trolley 1. I want us to see something. And then I'll do trolley 1. Please, you will do trolley 2. Okay. So F net. Once I say trolley 1, I'm going to use the mass of trolley 1, which is 0.5. I am going to use the final velocity of trolley 1, which is 2.4, positive 2.4, because I chose left as positive. Initial velocity of 0. And my time, what is my time? 0.12. Please, you do trolley 2 for me. Please, everybody, I've done trolley 1, and I explain what I did. It's the mass, final velocity of trolley 1, so mass is 0.5. Final velocity, its initial velocity is 0, remember? And I have a 0.12 as time of contact. So I have 10 newtons. Please, you do trolley 2 and tell me your answer. And let's do a bit of physics there. Bussy has a negative 10. More answers, please. Ahmad, why are you having a positive 10? You should be having a negative. And I really want us to understand why, because we must understand physics, which helps us with our answers. All right? Why? Good. Lovely. I love what you're asking me. Why negative? Come, let's work together. So what's the mass? That's why I wanted us to do it. Mass is 0, is it 0,3? All right. Beautiful. 0,3. Now, what is its final velocity? Negative 4. All right. Initial velocity 0. And what is the time? Now, this would give you negative 10 newtons. Remember what we chose. We chose left as positive. So it means the spring, I want us to interpret this answer. The spring is exerting left.
To the right.
On trolley 1. And 10 newtons to the what? Right. On trolley 2. That is why trolley 2 moves to the right. Did that make sense? Ahmad, did that make sense? That's why the signs are important, because then we are applying the correct knowledge of physics. And again, do you notice that we are trying to work again with what? Newton's what? Third law of motion. If object A exerts a force on object B will simultaneously exert a force on object A with the same what? Magnitude, but opposite in direction. And that's your positive and your negative. You don't have to do both of them, just doing one is fine. Describe how the acceleration of the trolleys would be affected if the mass of the trolleys were doubled. Lovely question. How will the masses of the trolleys, how will the acceleration be affected if the masses were doubled? What do you think? Let's do physics. How will the masses be affected if how will acceleration be affected if mass is doubled? How will acceleration be affected if mass, this is grade 11. We are looking at the relationship between mass and acceleration. Do you guys remember your Newton's second law? If a net force acts on an object, the object will accelerate in the direction of the net force. Acceleration is what? Inversely proportional to the mass. Do you guys remember that acceleration the object will accelerate with an acceleration inversely proportional to the mass, but directly proportional to the net force. So if we are doubling the mass, what happens? The acceleration will what? Decrease. And if they ask you for the reason, we talk about what? Newton's second law. The F net is directly proportional to mass, but inversely proportional to the heavier the object, the slower it moves, or the slower it changes velocity with time. And another 10 marks in the back. Oh, they said we should even explain. Ah, lovely. We should explain. What if you said inertia? Well, no, inertia would be wrong because inertia is the property of an object. Okay, we can kind of accept it, all right, but no, I'd love you to use the laws, all right? Acceleration decreases, and you just explain by using Newton's second law that mass and acceleration are, so let me write, according to Newton's second law, all right, I can just put all of that. Mass is inversely proportional to acceleration at constant net force. Inertia is the property of an object to resist what? A change in motion. So the object has a bigger inertia, but I would prefer you to work with Newton's second law. It's more applicable and easy to follow. I hope that makes sense, Papa Lelo. Are we okay with that? Awesome. Beautiful. But I love the fact that you're thinking of inertia. Beautiful. It's connected. So you'll still be on the right track. Okay, guys, that's it. Oh, my favorite, multiple choice. Come. Please don't come here and say we have rice in our home, but today we are eating beans. No, please don't do all those. What do you guys normally do? Many, many, many more. Bless the blood that I sleep on. Wada, 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 wada. Answer is D. There's nothing like that. You have 3 minutes. You know those things. And please don't have special answers to say, my special answer is C. You will get it wrong. So please work it out, calculate, and let's see. Read the question. Guys, do you need more time? Please don't guess. You must get an answer. We're not guessing. This is not if you need more time, I'm willing to give you more time. I'll give you 2 extra minutes. Think, walk through. Please, even 3 minutes. I want you to walk through. Please, no guessing. I want to teach you on how to do multiple choice. Very important. Okay, I see some of us have tried to guess and some of us tried to walk through. Those of you that guessed, thank you for guessing. And those of us that walked through, thank you for working through. And some of us, I'm sure you just didn't know what to do. Okay, so the reason I gave you more time was for us to be able to learn how to deal with such questions. All right, let's look at this together. Can you guys still hear me? Are you guys still here? All right, let's see. A car possesses kinetic energy EK when it moves at a speed of V. I like to always write things down. All right, speed is V. When the speed is V, kinetic energy, we know the formula, half mv squared. Which one of the following expressions represents the magnitude of the car's momentum? All right, let's see something. What is momentum? Momentum is mass times what? Velocity. Okay. But we need to write this in terms of kinetic energy. Okay, so if you look at my kinetic energy, half mv squared is half mv times v. Does that make sense? V squared. Wait, what is this? That's momentum. So EK is 1 over 2 momentum times V. We're looking for momentum, so let's cross multiply. 2EK equals to PV. Divide both sides by V. 2EK over V. Do we have that answer? 2EK over, there we go, D. This is how we work things out. Did it make sense? Let's see. Is there anyone who's confused? Let's see. Talk to me. Give me thumbs up or thumbs down. Let's see. Quickly. So it's a manipulation of stuff. All right? It is a manipulation of things. Make sense? Please put a picture of this on the group. I love it. Don't run away from multiple choice. Okay, so those of you that got A and B, you would see what you did wrong, and I'm hoping that you all understood. All right? Anybody sending through? For the sake of others who are not in, be a brother's keeper. Anybody wants to be a brother's keeper and send it through? Okay, I believe you got it. And all right, let's look at this 11 marks. Should I give you some time? Should I give you about 10 minutes to try? I want you to try. Let me see. Is there anything? Impulse? Now we're done. Remember what impulse is. Impulse is a product of net force and time. I want you to try this. And delta T. All right. So impulse is actually F net times delta T. And this is also the same in quantity as change in momentum. So please, I want you to try this. It's something that you can start by reading. Please, I'll give you 15 minutes. Start by reading slowly so you have enough time. High treasure, yes, it can be part of this topic. Mechanical energy can be part. I think I did it in lesson number 5. So please go to lesson number 5. I brought in mechanical energy into the topic. All right, guys, let us mark. I'm sure you were able to do one or two things from what the number of questions that we have done so far. You were able to pick. All right, so let's get through and walk through this together. A boy on a skateboard is initially at rest on a smooth horizontal pavement. He throws a heavy ball of mass 5 kg horizontally to the left at a speed of 3 meters per second. So he's holding the ball, right? Immediately after the ball is thrown, the boy's skateboard combination moves at a speed of 0.2. State the law of conservation of linear momentum. All right, I'm sure you got that one right. The total linear momentum in an isolated system, the total linear momentum in an isolated system is conserved. That is beautiful. Done. 4.2. The total mass of the skateboard is 2.5. Calculate the mass. Now let's go back to the story. A boy on a skateboard is initially at rest. All right? So it means the board, the boy, and the skateboard are together. So it means my objects are all together. Is that fine? So M1 plus M2 initial. Now they are then separated. The ball moves away. The boy and the skateboard. Okay. What do we know? We're looking for the mass of the boy, but they were initially at rest. Okay, so let me do this. Let M1, this is object 1, and this entire thing is object 2. Are you with me? The ball is 5 kilograms, all right? But we do not know the mass of the boy. Now, guys, when I say M2, M2 is boy and the skateboard. Initial velocity is 0. Okay? So, M1 again is 5. All right, let's choose left as positive. So that would be 3 plus M2. Now, what is M2? Okay, fine, M2. Now, here, a skateboard, please, I want you to look at something, is initially at rest. Let's apply Newton's third law here. Newton's third law states that if object A exerts a force, please, I want you to listen to this part. I think you wanted to catch us here. Object A exerts a force on object B. Object B will exert a force on object A, opposite in direction, but equal in magnitude. So the boy exerts a force on the ball in that direction. The ball will exert a force on the boy in the opposite direction, and the boy was stationary. So the ball pushes the boy to the right. You see, they didn't mention that here. Immediately after the ball is thrown, the boy's skate combination moves at a speed. You see, they didn't give you the direction. So the boy throws that object to the left, but the boy would go to the right because of Newton's second law, or Newton's third law. So there was a hidden information. Now we can calculate. Because if you don't do that, you'll be noticing you'll be getting a negative mass. And mass cannot be negative. You see, all of those things must make sense to you. This is 0, 15, minus. So some of you did not take that into consideration, and you were getting a negative. So that's why you're getting a negative. What is 15 divided by 0.2? That should be at 75. Is that correct? Yeah, 75. But what is this 75? It is the mass of the skateboard and the boy. So mass of skateboard and mass of the boy is what is 75. We know the mass of the skateboard to be what, 2,5, and mass of the boy we don't know. So what is the mass of the boy? 72,5. Talk to me. Are you okay with this? Are you okay with that? So please, when we do calculations, we don't just throw in numbers. We bring in the principle of physics. If you did not bring in that principle of physics, you would have written 0,2 here. And when you write 0,2 here, your mass will be negative. That already should start ringing alarm. Bam, 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 bam. Mass cannot be negative. Bam, bam, bam. You must start seeing that. Mass cannot be negative. So you've got to do something right. Is that okay? That's a monotone cartoon. All right. Calculate the magnitude of the impulse. Calculate the magnitude of the impulse that the boy's skate combination experiences when the ball or when the pass is thrown. We're looking for the impulse. Now, normally, impulse would be what? F net times delta t. Okay, this one, please, I would love you to see the way I'm going to interpret this whole thing. All right. Now, examiner wants me to get impulse. And I know impulse is F net. But the problem is I don't have that and I don't have that. There's no force, there's no time. But then we proved when we're explaining that impulse is also change in momentum in terms of quantity. Oh, so I can use this to calculate my impulse. You see, I didn't say over delta t. It's just change in momentum. All right, so we're looking at what? The boy's skateboard. Only the boy and the skateboard. What is the mass? It was 75, m2. What is their final velocity? Now remember, it moves 0,2 to the right, negative 0,2. Initial was 0. What's our answer here? Negative. What will that give us? Shouldn't that give us 15? Negative 15. Okay. Now, but how do I then write my answer? Now, the examiner says, always look at what they want. The examiner says magnitude. So we are going to ignore the negative 15 at the end. Okay. So we're just going to say impulse is 15. What is the unit? Go back to the formula. The unit of this is newtons. The unit of this is seconds. That's how we work it out. Although I used change in momentum, I am going to write the unit of what the examiner wants me to find. The examiner wanted impulse, so I write the unit of impulse. Please take note, although I used kilogram meter per second momentum, but my answer would be Newton second. Without any further calculation, look at this. Write down the change in momentum experienced by the ball. It's the same. Without any, the change in momentum is the same as the impulse. All right? And they have the same force on each other and they experience the same time in the same time. All right. So what's our answer going to be? Our answer will be 50 change in momentum. But now, change in momentum. Momentum is what? Kilogram mass, all right? And velocity, meters per second. Write down the change in momentum experienced. Are we on the same page? You see, without any further calculation. What's the final velocity? 3, initial velocity is 0, so it's positive. because it's moving to the left. Guys, are we okay? We're done with that question. Make sense? Let me know if there's any part that is not making sense. Let's do 2 more. All right, let's do 2 more. So you learn from this, you apply it in the next one. You learn from that, apply in the second one. We're good. But I need a multiple choice. I hope I can get one. Just when I said. All right, let's answer this one. Then we will answer one more structured question. Okay, this one is not so deep, but read clearly. Read the options. All right, are we done? Can I get answers A, B, C, or D, please? I want answers A, B, C, or D. Two identical solid spheres, each with mass m and traveling at a speed v, move towards each other in an isolated system. The spheres have a head-on elastic collision. Yes, guys, I'm not getting answers from you. Why? I'll wait. And then everybody's ghosting me. All right, I'm also ghosting you. Yay. Let's ghost each other. All right. Ghost versus ghost. Let's ghost each other. Thank you. I'm beginning to see answer. Pabalelo breaks the ice. Gives me an A. Meanwhile, others are ghosting you. Elastic collision. What does elastic collision mean? We explained that. Number one, momentum is conserved. And what it means is the total momentum before is the same as the total momentum after. All right, and number two, kinetic energy is conserved as well. Kinetic energy before, total kinetic energy before is the same as total kinetic energy after. All right, which of the statements is true? Number one is wrong. If the objects stick together, it is automatically inelastic. It's in our note. The total kinetic energy after impact is mv squared. Let's see. I don't think that is correct. Let's prove that now. Because it is elastic, we're saying that the sum of EK before is the same. And it will be half mv squared plus half. Oh, it's actually correct. Half plus half is 1. Because they both have mass m. The first one is mass m. Second one is also mass m. All right. Okay, check something here. Let me slow down. I think I've gotten my answer. All right. I'm working out the first one here, right? m1 vi1. m2 vi2. That will be half, mass is m, velocity is v squared, plus half, mass is m, velocity is negative v because of the direction. All right, but that would give us half mv squared plus half m. Half plus half is 1. And if that is before, it is also the same as after because it is conserved. Answer is B. The total kinetic energy cannot be 0. Objects are in motion. The total momentum before impact. This one is also wrong. Let me prove the last one wrong. If I look at momentum, total momentum before, let's prove it that is wrong. Will be what? m1 vi1 plus m2 vi2. M multiplied by v plus m multiplied by negative v. And that will give you 0. Are we okay, guys? With what I'm trying to explain? Did it make sense to you? Come talk to me. Did it make sense? Multiple choice is so important. Multiple choice is so important that we need to get it right. Please talk to me. Are we okay, everybody? Is it my network or yours? I don't seem to be seeing any response. Is there a delay? Okay. All right, there's a bit of a delay. Let's answer one more for the day, but I hope it's okay, guys. Multiple choice is just nice. Oh, it's actually multiple choice that we have left. You want to do this for me? Didn't we do something like this earlier on? All right, you should be able to do this. We did something like this earlier on. Come, quickly. All right, do you want to share answers with me? This one, you should be able to get an answer. Come, please. I need answers from everybody. All right, that was fast. I've got a D. I've got 2 people giving me D. Come, everybody, please. This one, I need everybody to make an attempt. All right, let's see. It says the vehicle is moving at a constant velocity v. We are given kinetic energy as k, momentum is p. We are looking for v. So what is the formula for kinetic energy? Half mv v squared. We are told this is k, this is half mv, v, and v. And we know this is 1 over 2, that is p and v. We're looking for v, right? So that is 2k over p. All right. Oh, beautiful. Let's end the day with this one, 8 marks. I'm going to take you through this myself, and we'll end it here today. This is very, very important. This is case study number 4. This is uncommon, so I needed to stay focused here. All right. A trolley of mass 5 kilogram moves at 4 meters per second east across a frictionless horizontal surface. A brick of mass 1,5 is dropped onto the trolley. Now look at, the brick is moving on the y-axis while the trolley is moving on the x. We are dealing with linear momentum, which is in one direction on a straight line. All right, guys, I'm sure by now we all know that. We've done that twice today or 3 times. State the condition for an elastic collision. We've also mentioned that. Condition for elastic collision is that both momentum and kinetic energy should be conserved. Before we can say something is an elastic. We've mentioned that over and over again. Now, let's look at this one. Calculate the change in the momentum of the 5 kilogram trolley. Okay, change in momentum is m delta v, which is m final velocity. All right. Okay, so we do know the velocity initial, which is 4. Okay, initial velocity. But then all of a sudden an object jumps on it. All right, please, let's see how I'm going to deal with that. I'm going to try to just walk in the space here, and you will then notice that both objects were separate before, and then all of a sudden together. So m1 vi1 plus m2, now they are together because the brick is on the trolley. But this is where it gets nice. Let's call this object 1 and let's call this object 2. Object 1 is 1,5. Now the question is, what is the initial velocity? Now, when object 1 is coming down, it's actually moving fast. But when it hits that second object, it starts moving horizontally. We are focusing on the horizontal direction. So its initial velocity there would be 0. I explained that under case study number 4. Now, what is m2? That is 5. And what's the initial velocity? 4. Here, what we have? 5 plus 1,5. And I do not know the final velocity. All right, do you want to get me VF quickly? That is 0 plus 20. That is actually, okay, let me do the maths just to make sure everybody's on board. This is 20, 6,5 VF. So we divide, right? 20 divided by 6,5. This one, it looks very easy, but if you are not taught. So please get back to lesson number 4, I think. I'm not sure now. And that would be 3,0769, because I'm not done. 0769. Okay, now I'm going to bring that in here by saying change in momentum is m vf minus vi. What is the mass? Now please take note of the 5 kilogram trolley. What is the final velocity? And it makes sense. The velocity must decrease, and its initial velocity is 4. We'll put that in a calculator. 5, 3,0796, or 69 rather. Okay. Negative 4,62. Now the question is, I want to interpret my answer. So, guys, I'm going to write my answer here. Change in momentum, therefore, is 4,62. Remember, it is mass and velocity. Mass is what? Kilogram. Meters per second. Now, that negative, what does that tell us? It's in the opposite direction of motion. In the opposite direction of motion of the trolley. Please, I want you to understand that 0. The object is coming this way, and then it changes direction. At that moment when it changes direction, on the horizontal, it is starting from 0. Please talk to me. That's a very beautiful way to actually close the class. Beautiful question. I love it. Talk to me. Are we okay, everybody? Did it make sense? There's more that is to be done. I think for momentum, guys, for momentum, we're going to have maybe one more class, a 2-hour session, which will be next week. And after that, we are starting with organic chemistry. That's very long. So while everybody will be in momentum at school, we will be finishing our we will be starting organic chemistry. That is very long and running through together. Please, we have one more session where we are going to answer a few more. I think I have a few more. Yes, you can see I have a few more questions for us to do. 1, 2, 3, 4, 5. Oh, beautiful. I'm going to add more graph questions to it. We will look at that for one lesson, and then we will be done. And then we move to organic. Guys, for organic, you cannot join us if you are not registered. It will only be accessible to our registered learners. I can allow you to see what's going to happen for the physics, but that would be the end of, so we end momentum together. But then we will start chemistry this month as well. So please start talking to us, 081-744-2103. Unfortunately, free things come to an end. Okay, so please start registering. Don't miss the chemistry class. Don't miss the chemistry begins in January. Have a lovely, lovely evening, everybody. God bless you. Don't forget, make inquiries.